Okay, I welcome you all for this assignment number one. It's a live session uh, related to the course dealing with materials data, collection, analysis, and interpretation. So this is presented by Sabari Rajan. Hello, hello. Someone has joined, but I hope I'm audible. Let's wait for another 5 more minutes. If someone joins, we can start the session right away. Otherwise, we can um, go like a pilot one. We will explain one by one questions. In between, if students join and if they ask some questions, we can answer to them. Okay, I hope we can start with our explanations, questions, because no one has joined so far. Yeah. So, first question is like state whether the following statement is true or false. Mean is a measure of central tendency of data, which is robust against the extreme values of the data set. So, basically, we know there are three parameters or three parameters which can measure the central tendency. One is mean, median, and mode. So first is mean. Mean is the average or adding all the values divided by the uh, number of variables which you have taken for the consideration. So mean gives the central tendency in terms of values, but median gives the central tendency by considering the number of points and what is the center of that. So yeah, we will discuss with some example. It will make it more clear. Hello, hello, Vasudevan.
Hello.
Yes, Vasudevan.
Sir,
There,
is this link correct?
yeah, you are here for live session regarding this dealing with materials data collection, analysis, and interpretation, right?
Yes. Yeah, I got the mail.
Yeah, exactly. Yeah, this is the link. It's the correct one only. Some people have not joined, I guess. But anyway, I'm explaining based on what are the questions given. So it will be
Okay.
available in YouTube later. It can be
Okay.
referred by people who are not attending this. So
Okay.
yeah, do you have any specific doubt, or should I go with the each questions?
And then, you can plan with the question, sir. I'll ask in between if anything comes.
Okay, yeah, fine then.
Sir, thank you.
Okay, present it. Is the screen visible, Vasudev?
Yes, sir.
Oh, you are from which background? Metallurgy or?
No, I'm background with civil actually,
Oh, okay, okay, fine.
civil and agriculture. Yeah.
Civil and agriculture. Okay.
I think there's a doubt there's a confusion in the mail. It is saying 28 Monday. Actually,
Yeah,
that may
yeah,
be the reason people are
yeah,
not
yeah.
joining.
I hope so. I mailed them regarding this, but I think it is
Okay.
too late to give any
Correct. Yes.
corrections to that.
Yes.
Anyway, there's no issues. If
We
this
can
this is
again see it
available, yeah,
available.
this is
Yes.
available in online YouTube. But yeah, and if someone is interested, also next live session also we can discuss with. It's not a
Sure.
problem. Yeah.
Okay.
So yeah, I will go with the first question. I was discussing about this. So first question is state whether the following statement is true or false. Mean is a measure of central tendency of data set, which is robust against the extreme values of the data set. So yeah, the thing is mean, median, mode. All the three is the measure of central tendency, but each one has its own significance. For example, mode is a different thing. Let's not bring the mode into this. But if you consider mean and median, right? So, for example, a population has a population of 10 people. We can take their earning from 30,000 to 1,50,000. Okay, let me write it down so that it will be easy. So, the income, let's take it like 20,000, then 30,000, 40, 50, 60, 70. So I have taken 6 and 7th person is running around 90 and 8th person around 190. So if we take the mean, right, yeah, we can try taking the mean. So it's coming around 60. So mean is around 60. But if you see the overall population, right, they are earning between 20,000 to 70,000. That is the maximum. And if you take the median, okay, if you take like some odd number, it will be one more easy. So we will include the 18%. So, so the median is around 60, but because of the inclusion of 80, like the value increases to around 62.2. So when this is significant is like we will be devising a budget plan or something based on everyone's income in that particular area. Because of someone who is earning more, like 1,20,000 or like 1,50,000, the other person who are earning in this lower circuit will get affected. So whenever we are considering this kind of whenever we are looking at the data set, it is better like we should consider both median and median and mean. So based on the application, we should choose which one is better. So in this case,
Yes.
if you would have gone for mean, then the population which is in the lower circuit will get affected. So same thing applicable to some metallurgical problems also. Like when we are doing some testing, we may get the like we will be repeating the sample many times, and for different conditions we will be doing different tests, and we will be getting many results. In that we may have one or two odd result. So while taking
Extreme values, right?
yes, exactly. So those extremes will be like if we take them into account, the mean value will get affected. So it is better like that time we can consider the median or like we can exclude that extreme also. So when considering this, the robustness to the extreme values is given by the uh, yeah median. Mean is not the measure of mean doesn't give the robust value against the extreme. So this statement is false. So let's go to the second one. Yeah. If x bar is a mean and is standard deviation denotes the mean and standard deviation of the data set, then x bar plus or minus s covers the dash of the data with the assumption that dash is distributed. Okay. So the thing is, generally, this problem mostly the people in the industry will have day-to-day experience because their aim is to reduce the number of defects. So what they one second, someone else has done.
I'm sorry, I got disconnected in between.
Okay, okay, fine, fine.
Yes, please.
Yeah. So I will explain the second one again. I hope you went in the second question. Okay.
Yes.
Okay. So second question it deals with the okay it is given like x bar plus or minus s covers last percent of the data with the assumption that the data is how it is distributed. So this problem is commonly observed in the industrial places where you can see like they will be trying to minimize the defect. So
Mhm.
by saying that the defect, the number of products which qualified should be within like 99.99% of the things. And you would have heard about the Six Sigma certification
Six
course.
Sigma. Yes,
Yeah,
yes.
all those things. Why it is because like they have to minimize the defect. So it is like in ppm level they have to reduce it. Like only in 1 million, only five parts will be defective like that. So
Yes.
this is where the application is like very important and most widely used. So yeah, here it is like 1 sigma means in normal distribution, it tells like with 67% of the data will be normally distributed within that given range. So this is what the explanation for the 1 sigma rule. Yeah. So it is 67 percentage normally distributed in the normally distributed. Why normal distribution is because it brings the normalization into the account. You can normalize the data so that it won't change with respect to the what is it, the extreme data sets or the mean and median. So that's why we generally do the normalization. And in normalization, if it falls under 67 percentage of the uh, 67 percentage, all the data set falls under 67 percentage, it is then 1 sigma. Considers 1 sigma.
Sir, what is
Yeah.
the difference between normal and uniform, sir?
So uniform distribution means we want.
Both sides of the are
Uh,
mean center and both sides are uniform. Is that?
no, no, it's not like the uniform distribution is an entirely different distribution. Maybe in the end, I will give you some example. Like,
Okay, okay, sir.
you want to know what is uniform distribution. So yeah. So next we will go. Like later we will discuss all this.
Okay, okay, sir, please.
But uniform distribution is different from normal distribution because uniform distribution it deals with um, the data set which are like almost similar. Like, it's not like varying with respect to the different. For example, if you tell uh, like some population of people having some height, you can consider as normal distribution because like only few people will have the height of around 180 centimeter, but
Yes.
others will be distributed in that plus or minus range. So
Okay, okay.
that is the way. But if you take some data sets like the value of the for example, in civil, if you consider meteorological problems, right,
Okay.
where the value of the measured size of the brick or something like that, so it will be standard. It won't vary much. So for that, the uniform distribution fits well.
Oh, in that sense, okay, sir.
So let's go to the third question. So I hope you are aware of this cumulative frequency plot. So what it tells is like how the values uh, in some it is distributed. For example, if it is like distributed.
So the screen is not moved, sir.
Oh, sorry, one second. Yeah,
Okay, now it's clear, sir.
yeah, yeah. Now we can see, right?
Yes, yes, sir.
Okay, yeah, in community distribution plot, it tells like how much frequency of the values are falling under the given category. For example, here number of minutes. Okay, one second. It has taken number of people who are exercising for given minutes. So they have
Okay,
taken like from people generally for do from 0 to 60 minutes. 0 means people who doesn't do
yes,
any exercise, and if 10 means how many people are doing 10 minutes. That is like one. So that is what you can read from this plot.
yes,
Like, I think you can see the cursor, right?
yes, yes, sir, yes, sir.
So 10 minutes is one, and then if you take 20, it is something around two. Like that, it has been distributed. Yeah. So the plot can be like can be a linear plot, or it can be like yes,
Yes, step.
it can have a step, or it's like point inflection points can be there, or it can be like a parabolic kind of thing. So it all depends on the data set. It is nothing like anything particular.
Yes,
So here, what we have to take is, one second. So here, what we can read is like, so whatever being in this from 25% to 70%, right? So this is called interquartile range. You might have studied in the Bhaskar and
yes,
Box and Whiskers plot. So we'll be discussing that also again. So that time I will explain it clearly. So the lower quartile is this 25% of the data lies below this value, and median is the 50% data. Like whatever we have calculated the median or like average, right? That will be the this particular value. So from this plot, what we can understand is like on an average, like people have exercised around like what we can tell from this something around 33 or 34 minutes, like that is what we
Yes.
can tell.
Yes.
On average people are doing, and 25 percentage of the like at least 25%, 25 percentage of the people are doing uh, uh,
In 25 years.
yeah, close to 25. Yeah, that's what we can tell. So this is how we should read the data. This can be a like I'm
So,
just, yeah, tell me.
sir, is it the correct? Is it based on the definition of median, sir? Because the answer is median, right? This is same as the definition of median.
Uh, yeah, exactly. Yeah, it is like same as the definition of median. Here, median and mean, like if the skewness is more, that will change. Like if the data where you can see the extremities values are coming into picture, right? It will change.
Okay.
But here it is like we are mostly talking in terms of frequency, right? Frequency means
Yes. Yes.
how frequently you are observing. So here
Observing.
it
Yes.
is, yeah. Okay, if I have told like mean by mistake, it is wrong. It's median only. I don't know like whether
Median.
I,
Right.
yeah, it's median only. So how frequently it appears, like how frequently people are doing. So that's what here it matters. So it's always about the frequency.
Okay, sir.
So here the mean value doesn't come into picture. Like,
No,
sorry if I have used the mean value.
no, that's
Mean,
correct. Yes.
yeah, fine. So yeah. So this interquartile range like will give you like how much percentage of people from are working out in the given range, like 25 to 70%, or one sigma we can call it as. Yeah. And this can be drawn as a normal distribution also. Like I hope you are aware of this also. So this can also be drawn as the
Okay. Okay.
distribution. Yes. So the answer to this is median.
Median. Yes.
Yeah. So going to the fourth question. Um, the correlation coefficient of two sets of data can take the values ranging between. Okay, before that, I just want to know like what do you understand from correlation coefficient? Like, can you please explain like from whatever you have understood?
Uh, what I understand is if there are two sets of data,
Okay,
um, we can relate to them as
okay,
if one is changing, then how much the other is correspondingly changing. That relationship is given as an expression. So if it is linear or non-linear, all this based on the how much they are equally changing that
yeah,
relationship.
yeah, exactly. Like we are just trying to correlate their relationship. Like for example, if we I think they have given an example. Okay, let's discuss it later. So if I have okay, you're from civil, right? I can give this example. You are aware
Yes.
of the hardness, right? So
Yes.
hardness
Yes.
and strength, how they are varying. So if I have some data set like around hardness varying from 200 to sorry, because hardness if I take if it is varying from 200 to 400, and if the strength is varying from 300 to 800 in increasing way, which means like we can say okay, I will just write it down here. So because hardness value varying from 200 to 400, and if the yield strength is varying from 400 to 800 MPa. So here you can directly tell with increase in hardness, the strength is also increasing. Like they
Yes,
have
sir.
positive correlation. So whenever you find this correlation coefficient, right, it lies between 0 and 1. So if I plot the correlation coefficient curve, right, it will be like it may be straight line depending on the value. If it is 1 means it is linearly correlated. If it is some value like close to zero point 0.8 or something like that, means the curve will not be a straight line. Instead, they will have it be a polynomial function. So, but one thing which is clear is like with increase in hardness, let's put like HV here and sigma y here. With increase in hardness, the yield strength value is increasing. So from that we can understand, so hardness and yield strength have a positive correlation. The another thing what we can tell is like you can ask like it is very clear by seeing itself it is positively correlated. Why we need to use this correlation coefficient? So this is like when you have something finite data set. If you have infinite number of data sets where you don't have any direction, like people would have taken the experiments in a random way, and you won't have
Yes.
any correlation when you are collecting the or assigning arranging the data. So that time when you in later stages sir will be explaining how to use R language to calculate all these functions.
Okay.
So that time you will, if based on you can, even if you have n number of data sets, you can easily correlate them. You can arrive at a particular value, and from that you can decide how the correlation is. So this is what this is why it will be useful.
Okay.
So on the correlation coefficient of two data, here the answer is like, okay. Before that, a correlation coefficient formula is the covariance of x, y divided by square root of variance of x into variance of y. So covariance of x can be covariance of x formula is the xi minus x bar. It's mean of
Mean
x,
value.
yeah,
Yes.
and yi minus y bar. I think this is missed.
Okay.
So this is it is also mean value. So
Yes.
here you may have if you would have
Negative
referred to
values.
yeah, if you would have referred to multiple sources, you will have a confusion whether it is n minus 1 or n. So if it is for
Okay.
samples it is n, and for population it is n minus 1 changes.
Oh, I see. Okay. Okay. Thank you.
This is the thing. Yeah. So here the correlation coefficient of two sets of data can take the values ranging between -1 to +1. This is the answer.
Yes, sir.
So, but it's not only bound to minus half to plus half or
Mm.
0 to 1 or 0 to 1 by 2. It can take up any values from ranging from -1 to +1. So going to the first question. So the following mesh methods is or comma is or not common measure of central tendency. So we have discussed before, like these three methods are the measure of central tendency.
Sometimes, yes.
So which means like the range gives the upper and lower limit. So you can see from this image, right? Like
Okay.
there is a
Okay. Yes.
distribution of height where you can see like from this we can know what is the lowest height where people are coming, and what is the tallest person who is coming. So why it is used, where it is useful is like if you are what is it?
You want to
If
cover
you're
all the people.
exactly like if you are constructing a place where the constructing a place or like a stadium, the bottom wall or the wall which is supporting us from going to the next stage or something like that,
Yes.
where it should be bottom should be designed based on the lowest height, and
Lowest height. Yes.
top whatever while entering the top of that roof should be based on the like tallest person.
Tallest.
So
Yes. Yes.
where this will be useful in those places. And this can also be used for this industrial engineering, where when you are making are you aware of this go non-go gauge?
That I'm not very sure, sir.
Okay, fine. So okay, like
Tolerance is correct. No, tolerance is different,
yeah,
I think.
it's for tolerance only. Like upper
Okay.
and
Okay.
lower tolerance. Based on that, they
Uh-huh.
will design one gauge. So that gauge
Yes. Yes.
they use for testing, checking the sample in production line. In production line, you cannot take each and every sample, and you cannot check the sample.
Yes, yes.
using the vernier caliper. So they will have a gauge. If it is like if it is like a cylindrical object measurement means they will
Ah,
have a cylindrical gauge. They just put it. If it is going inside, they approve it. If it is not going in, they just
yes, yes.
yeah. So that is how they use. For that also, this range will be helpful. They design it more than they design it within the upper range, so that if it goes, it is fine. If it is not going, or like if it is too loose, they will reject it.
Yes, yes.
That's all. So standard deviation, as we all know, like we will know how the what is the spread of the data. So we know what
Around
is the,
them.
yeah, we know the median. From that, how the spread is. So this we have a lot of applications and everything where we are every day we are using. For example, if we do an experiment, we cannot always repeat a value. For example, if I'm getting some yield strength, if I'm doing three sample for steel, so if I'm getting around 600 MPa in the first test, next test I will be getting around 630 MPa, and next
Yes,
I will be getting around 610. So from this I can take the mean value of around 620 plus or minus 10.
yes.
So this is how the experimental and scientific data are represented, because like in future someone has to reproduce it. That time they should know whether it
Check
will
the range.
fall under
Mm.
the limits or so that is the thing. So with the sixth question.
So standard deviation can also be accepted as a measure of central tendency.
Standard deviation will give only the spread. It
Spread.
does. Yeah, this value is the standard deviation. It has nothing to do with the central tendency. Mostly, this
Central
mean median
tendency.
mode is used for central tendency.
Yes, yes,
These
yes,
two
yes.
gives the spread of the
Spread
central
of data.
tendency.
Yes,
Yeah,
yes.
spread from the central tendency.
Okay.
So yeah. And if I want to give you one more application of day-to-day, my application for standard deviation is if I compare two material and if
Mhm.
I'm getting frequently rise around 610 MPa of data for one, and
Mhm.
another one 630 MPa. So generally what people think is like there is a 20 MPa improvement. So there is an improvement in the strength or something like that they might think. But once you get the standard deviation, if I am getting like plus or minus 30 MPa, and here I'm getting plus or minus 10 MPa, and it doesn't make a difference at all, because the higher value is 40 MPa, sorry, 640. So
It's what
it is coming into the limits of this sample. So that is how the standard deviation should be taken into account, like whenever we are into the experimental field or even practical applications.
okay.
So going to the sixth question, for negatively skewed dataset, which of the following is correct? Okay, so negatively skewed means the tail will be on the lower segment. So this is called the tail. So this is negatively skewed. Positively skewed means it will be on the tail will be on the upper segment. So if it is balanced, the symmetrical distribution means it's not skewed or zero skewed. So that is what they call it as. So why it is important is like if we have a data set where mode value is like dominating. For example, as I told you before, like if I have people who earn more, like 50% of the people are earning from 30 to 50,000,
Mhm.
and or like if we take 70% of the people are earning from 30 to 50,000, and only the 30% of the people who are earning more than 1,20,000 or 1,40,000, then our curve will move towards the right, because the uh,
Mean will.
yeah, one second. Sorry, I'm talking about the positive skew. There, the mean will be dominating. But if you see the frequency of the data, like most of them would have been earning between 30 to 50. So that is where the median comes into picture.
Medium.
And also the within the 30 to 50 only, the mode also will be high. People who are earning between 30 to 50 will be repetitive. They will be coming more
Okay.
into the picture. But in, mean value will be higher. In that case, the positive skewness can be seen. In the other way, like if you can see, like few people are I can say the data set where yield strength or ultimate strength I am calculating, where one material has a defect because of that it is failing early. So in that case, or one or two samples like casting defect you can take, or like some cracks which is already been present in that material. So they are showing like around 400 MPa, 400 MPa. 30% of the data is showing around 400 MPa, but remaining all the sample are actually showing correct value of around 800 MPa.
Okay.
So at that time we will have what's it? Yeah. That time what will happen is like um, one second. Yeah, the mode will be on the near 800 MPa, and median will also close to the 800 MPa because we have most frequently the data has been seen close to 800 MPa, but because of this 400 MPa and close to that few data which is
So mean will down.
yeah, mean will decrease. So that because of that the curve will look like this. Got it right.
Okay.
So, but in
That's
case,
great.
yeah, but if in case like you have a material which doesn't have any defect or anything, which is reproducible like close to 800 MPa means the curve will look like this, where it is like symmetrically distributed. Yeah, this is how it will look like. And more general application is like if you take population, like in India, the uh, height of the population will be like lesser compared to the other countries. So if we take overall population, if Indians are 30% of the US people are replaced by Indians, then we can see the median value high, but the mean value, sorry, the median value will be high, but the mean value will be low because of the shorter people. So this is how the curve will look like. It will change from the symmetrical distribution to negative skew distribution.
Okay.
So going to seventh question. You can able to read the data, right? Like, is it clear?
Ah, yes, sir.
Yeah, anyway, I will read for. Experimental values of the diffusivity of silicon in germanium is given in the table below. Calculate the correlation coefficient between the temperature and diffusivity, where what we can infer from these values. Okay. So if we plot this, right, this is how the plot will look like. The
Okay.
black one is like, wait,
Discrete data, right?
yeah. Yes, it is discrete only because it doesn't have any population uh, kind of function. Where you can see the this is what I have plotted. It is
Okay.
increasing gradually, and then suddenly it is skyrocketing. So this distribution looks like the exponential distribution. But sorry, I have drawn something. Which is like when we fit a function to this, right? Generally
Okay.
what we do is like when we will be fitting a function to the given data set to to generalize with or to predict the further data. If I know if it follows the exponential function means what I can do is like from this I can calculate for 27 mm square what would be the temperature like that. So for that
Okay.
generally we do in experimental yeah, field we do the fitting for all the data
Fitting with,
uh,
okay. Fitting the function. Yes.
yeah, fitting the data with some function. So if you see it closely resembles the exponential and also it is closely resembles the parabolic also. We have various parameters to check how much is the efficiency of the fitting. Based on that, we will finalize it. For this, the exponential function fit was close to the one. So we have kept the exponential function fit, and from this curve itself we can say like it is positively correlated with increase in temperature diffusivity is increasing.
Yes. Yes.
But anyway like we can use our correlation coefficient function, and we can check whether the observation is correct or not. So for that what we need is first we have to find the covariance of x and y. For that again we need yeah, we need to find the mean of temperature and mean of diffusivity, where I have already calculated to just save the time. So mean of the x is let me keep temperature in the x temperature as x and diffusivity as y.
Yes.
So that's how I have plotted also. So if you say, check the mean value, it is close to 625 degrees Celsius for the temperature, and mean value of diffusivity is 6.007. Yeah, I think it is mm square per okay, nanometer square per millisecond. Yeah, it is nanometer square per millisecond. It is written. So yeah. Now what I have to do is like just I have to put it back in the formula and get the value. The summation of xi means it is the first value. It is 5.
So we need to do this with a table type of calculation only, sir, or any other short way.
Not table in the sense I'm not getting. Sorry.
No, we can put two more columns for Covey x y x minus x bar. Like this, continue with a table to calculate it easily.
Yeah, you can use tables also. Like generally, you can use Excel sheet to
Excel is
make
correct, yes, sir.
yeah make the work easy. So just for explanation, I'm just writing it and explaining.
Yes.
In later stages, when you are familiarized with the R language, right, like the software, you
Mm.
can just with the code you can get these values. You don't have to just you have to input the X data set and
Okay,
corresponding
sir.
Y data set, and just you have to use the code, and it will do everything internally. That's why the if you see the course if you check the course flow carefully, right, they will be giving some theory based things first, and then
Then practice.
yeah, the background first, then the corresponding coding and everything practice, everything will come at the later stages. So just to know, like without basics we cannot just like, see this
Yes,
can be
yes.
going this can also be taken in this way. For example, if you know the correlation coefficient, if it is positive, it is positively correlated. Negative -1 means it is 0 to -1 means negatively correlated. But without the background of how these formulas or
Practice
how
with
this
them.
evolved, right,
Yes.
it will be difficult. So yeah. So first we will be finding the covariance of x and y. So for that, x. Okay, first one is 550 minus
625.
625. Then uh,
600.
yeah, sorry, into this data set and yi 6.007. Sorry, uh, sorry, 0.01
0.018 minus
6.007. Okay.
plus
1 second. Plus uh,
600 minus 625
600 minus 625 into uh, 0.31
0.7 minus
6.007 plus uh, 650 minus 625 into 2.7 minus 6.007. So from this y value itself, we can see like it is going from 0.018 to 0.31, then 2.7 to 21. So it's like exponential growth can be easily observed. So 700 minus 25 into into 21 minus. So can you tell me the covariance value to your calculator, please? Hello.
Hello, sir. Yes.
Have you calculated the covariance value before?
No, I'm not sorry. I'm not used the calculator right now.
Okay, okay. Okay, then let me do it. Just give me a minute. Uh, Covariance of x comma y is equal is 1798.7. This is what
Okay,
I'm
sir.
getting. Okay, then we have to find the variance of x and variance of y. So read next page. So variance of x is nothing but like whatever we have calculated so far, first value, right? First set of values that will come into variance of x.
Maybe that Excel sheet will be nice to do that.
Yes,
Easy
yes,
to do that. Yes.
exactly. Yeah.
It's okay, sir. It's understood now because you given the equations correctly now.
Okay. So yeah.
N is 4, so n minus 1 will be 3, right?
Yes, yes, yes. Three.
Okay.
So if you find the value, it will be like anyway first, the major thing is like the positive or negative depends on the covariance only. Correlation
Okay. Okay.
coefficient positive or negative depends on the covariance
Okay, sir.
because anyway the bottom one is a square. Square means even if you get the negative value,
Become
in
positive.
this case it will become positive. So it's a positive
Yes,
function.
sir.
So the sign depends on the numerator.
Covariance.
Yeah, covariance of x and y. So since we have got the covariance of x and y positive, we can tell like it is positively correlated. But when you calculate the value of the correlation coefficient, we can tell their shape, how it will look.
Okay.
Since it is like exponential, it may be like close to zero point 0.2 or 0.5 something like that. Anyway, like when you calculate it. So answer to this is temperature and diffusivity are positively correlated.
Yes.
Uh, this can also be one answer. Uh, it's negatively correlated is not. Then the relationship between the temperature and diffusivity and plotted can be seen not linear but exponential. Yeah, this can
Yes, sir.
this is also.
Yes, sir.
So going to the eighth question. So it's like a kind of reasoning question based on the statistics. So
Okay.
a group of material researchers has developed two types of alloys for high temperature application. So two materials have been uh, tested at the same temperature and stress level. And then the box and viscous plot below show the creep life for two alloys. They have given like both the alloys are tested under same conditions and same number of times, so we don't have to worry about the reliability of the data.
Okay.
As a design engineer, which alloy would you prefer for high temperature application? Yeah.
Okay,
So
sir.
the thing is, first let's interpret the data like how it is.
Mm.
So from this we can see it is like mostly they are negative skew can be seen in the curves. So which means like we have some most of the distribution which are between which are under upper quartile range, like from 1001 to 1800 or
Okay.
1200 to 1300. So that is what it means. And then so they are asking us like how will you decide like which material like either alloy A or alloy B. Service life, like creep means it is a time dependent plastic deformation where they just apply some load and then they just leave it for a number of days. Even at stress lower than the yield strength, they will deform. That is the creep deformation is.
Okay.
You might have observed this in tungsten filament, bulb
Yes.
tungsten filament. So over a period of time, they just deform. They are not
Mm.
under any load, but still they are deforming and they are failing. So that is a perfect example of creep. And one more thing is iceberg movement. Like
Uh,
they are in Antarctica. They are well below the temperature where they can undergo initial change, but still they will be continuously moving and melting. The reason is because of the creep only, the diffusion happening between the atoms.
yes.
So that is basically creep. So creep, uh, they generally discuss based on the rupture line. So how much time it is taking for a material to fail under the given rule. That is what they have shown. That is what the data they have shown here. So you can see the service life of the alloy A has the range from 600 to 800.
Okay.
So with the mean of 1200. And if you see the alloy B, it has the sorry, it has the range from 900 to 1500 with the mean of same 1200. So this one thing which we can see from the alloy A is like some of the data have shown that the strength is sorry the rupture life is very high, around 1800
Eight.
yeah, hours it has shown. So if someone takes the decision that since it is showing 1800 hours of rupture life means but when you see the lower it is 600. So the spread of the data is first of all too much. So that's a major drawback in this now. And then when we compare the median of the data, like 1200 and 1200 are almost same. So now we have if it is showing something around 1300 or 1400, right? Then we could have straight away gone with the alloy A because it is showing
Eight.
higher rupture life on an
Eight.
average. But since both are showing same rupture life, but uh, that's why like we should look at the other parameters. So let's go with the options. So alloy A because the maximum service life for the alloy is 1080. That's how I told. We cannot
Okay.
just with the maximum range we cannot decide because the lower range
Mm.
is also 600 MPa, that's 600 hours. So then second option is so first option is not a correct one. We cannot choose this.
Yes.
The second option is alloy A and alloy B have equal preference because the mean service life for the both the alloys are same. So this also cannot be the true because that's why I told. Mean can be same, but their distribution also matters. That's what we have
Yes.
learned from
Range is
engineering.
different.
Yeah. So alloy B because the data spread the interquartile range is less. Yeah, this can be a consideration because the interquartile range gives the most number of data or kind of standard deviation where you can see the interquartile range is less for the
Okay.
alloy B. So this can be considered. Then alloy B because lower quartile range is between 900 hours and 1000 hours, which means like it is likely to fail before 900 hours. This is also a valid point because in this case we can expect a failure in 600 to 800 hours also. So that is also
Yes.
like 25% of the data lies in that. But if you see
Yes.
here, the 20% of the data uh, is between
Very much.
900 and 1000. So the lower quartile range is far above the 900 MPa, sorry, 900
Yes.
hours. Sorry. So hence, considering this point, this fourth option, also we can decide the alloy B. So both C and D are can be considered.
Sir, is it necessary to have that temperature stress data, or just this hour is sufficient? Service life is alone is sufficient, right?
Yeah, service life. This is the output of the test.
Output
So
of that test, I guess.
this is enough. For example, if you do tensile test for your specimens, right, in your
Mm,
civil application, so
yes,
where
yes,
strain rate also or cross-head velocity also a testing parameter. But
yes, yes.
generally we keep that as constant, so we don't bother between
Okay,
each
okay.
and every sample. So we just
Yes,
consider
yes.
the yield strength, ultimate strength, and ductility of the material.
Okay, okay.
Similar thing applicable. Let's go with the ninth question. The ninth question is the simple probability problem which we have solved so far. We have solved in our 12th grade and 11th grade. So this one, if you read the question carefully, a bag contains 8 white balls and 2 black balls. And second, okay, let me draw 8 white balls and 2 black balls. And then second bag consists of 5, 5 white balls and 3 black balls. And one ball is drawn at a random uh, and placed in the unseen in the second ball. So we don't know while replacing what ball we have taken from the first one. So
Okay.
they are asking what is the probability that the ball drawn from the second bag is black. So this is first one. This is second one. So here what we have to know is we have to consider two cases here. So while taking this ball from first bag to second bag, it can be a black ball uh, or it can be a white ball. So first, while considering this as black, and then both the probability we have to consider. So
Okay.
both the
Two
cases,
events.
yeah, two events also we have to consider. So considering the first one is a black ball. So 2 by 10 is the probability. 2 out of 10 can be taken into
Yes, sir.
here if it is black means 4 by 9. So whatever one we are taking from here and placing it here, so it is 4 by 9.
4/9.
Yeah. Plus, if we have taken white ball from this, then the probability of taking white ball is 8 by 10.
Mm.
And after that, probability of taking black ball is 3 by 9.
9.
Yeah, because we have added one ball from here. So 3 by 9. So from this, if we calculate, it is like 8 by 90 plus 24 by 20. It's like 32 by 90. 16 by 45. Yeah, 16 by 45. So we have that answer here. So it is 16 by 45.
Okay.
So 10th question. So here it is a probability distribution function of a discrete random variable. X is represented. X represents the number of defects in a cast product as follows. So this is a function. F of x is equal to okay. F of x is equal to c into x square plus one, and c is a constant here. And they are asking us to find the value of the constant. So where the variable x can take up from 0 defect, 1 defect, 2 defect, and even 3 defects. That is also possible. So like that they are given. So for what we have to find this, first we should know the sum of the probability is 1. So that is a basic understanding we generally get from the probability. So what just we have to do is like we just have to do the summation uh, with x varying from 0 to 3 uh, in this function x square plus 1. So if we do so, c into x is 0, it is 1 plus um, 2c plus 5c plus 10c equal to 1. So then if we add, it will be like 18c equal to 1. So c is equal to 1 by 18. So this is the value. I think if we give the decimal values, it should be. And if they have given a probability density function where they are represented in the integration, like f of x into dx, like that means what we have in a given interval from 0 to 10 or 0 to infinity. For example, if it is a standard normal distribution, right? It varies from, like, they can ask you the uh, at the time what you have to do is like minus infinity to plus infinity. The value ranges from minus infinity to plus infinity. So here we can take from minus infinity to plus infinity. Otherwise, sometimes they will give from 1 sigma means the corresponding value we have to take. So uh, but here, like for finding the total probability density function, we should know from minus infinity to plus infinity, it is 1. F of x dx is equal to 1. So based on this, like if you solve using the integration and substitute the limits, you will get you can get the constant value. What is the value of the constant?
Oh,
This is also possible. So yeah. The 11th question is the mean of the random variable x is given to. Okay, so first of all, this moment of random variable we should know. So what is zeroth moment? What is first moment, second moment, or kth moment? So for that, uh, generally moment of the random variable is given by mu n is equal to expected value of x to the power n. So this n only decides what is the moment. So if you tell zeroth moment means n is equal to 0, and if you tell first moment means n is equal to 1, second moment
okay.
means n is equal to 2. So if you see mu 1 is equal to expected value of x. So this is nothing but the mean. So, are you aware of what is mean the expected value?
I forgot actually. I heard, I learned sometimes back, but I forgot it now.
Okay, okay. I will try to give an example. So, when you are doing,
Is it coming from probability?
yeah, exactly, it's from probability only. So, if you throw a die, you can get one, two, three. I mean, single die. You can
Yes.
get values from 1 to 6. So, expected value means what is the value which you can expect most probably. For example, while throwing, the probability of each, it is equally likely. So, probability of getting each one is 6.
1/6.
Yeah, so 1/6. Sorry, yeah. 1/6. So based on that, what I can do is like, one second. One second. So expected value of x is equal to summation of x into p of x.
Okay.
This is the formula for this. So if we substitute like x is equal to 1/6, right? Sorry, probability of x is 1/6, and in this case x is 1 plus 1/6 into 1, 1/6 into plus 1 by 6 into 3. So in the end, we will be getting a value which is similar to whatever we do, like adding all the values dividing by 6. So that is
Okay.
mean. Got it, right?
Okay. Correct.
If we add this, what we are getting some 14, I think 21, right? 21 by
21 by
6. It is something around 3.2 something it will come. So this is what the value you can expect. So if I throw a die, I can easily expect like the value can be 3.2 or 3.
yes.
It can be 3 or 4 like that I can expect. It's all based on the probability. This is the first moment. First moment
First
means
one.
where the n value is 1, which boils down to expected value. So
Okay.
if it is second moment means value is equal to means it is e of x square. So this is like squaring each value and then dividing. So that is what the thing is. Wait one second. Okay. So how it will look like is um, 1 by 6 into um, 1 square plus 2 square plus it will go on. So this is also called second moment is also called variance. E of x square is called variance. So it is like general variance. It's not like you can ask variance means we generally calculate x minus x bar the whole square like that. But that is like variance for a given variance based on the mean value. But this is like a generalized variance. So we tell variance means this okay. If we calculate this, we can tell. So it will be like 91 by 6 will come. So we take the square root of this. So I'm getting okay. Variance is around 15 point something. But if I take standard deviation, it will be around 3.9,
3.9. Yes.
3.9 or 3.8. So
Okay.
we can tell like from 3.2, the value can go up to 3.9, and the difference, like what I could say is one second. Just checking the calculation. Yeah. Now just the variance is 3.9 something it is coming. But with this we cannot easily correlate. So what we can do is we can find variance with respect to the median, which is generally calculated using second moment minus first moment of random variable square. So this one you might have seen like expected value uh,
Okay.
e of x the whole square minus uh, e of x powers 2 like that. So this is how generally we calculate the variance of x. So from this we can see just 21 by 6 percent. Variance is 91 by 6 minus 21 by 6 the whole square. So if we calculate this the whole square 12.25. This is 12.25. So 15.16. It's 2.91 as a variance of x.
Okay.
But we have to find the standard deviation. It's 1.7. We take the square root of this. So
Square root of variance.
square root of variance, if we take, we'll get the standard deviation. So standard deviation is 1.7. So it tells like we can expect the value of 3 point, that is 3.5. That's how we calculate it.
3 point
3.5 is the average. From that we can expect plus or minus 1.7.
1.7.
So second moment is just a generalized variance. Uh,
Mm.
Using both, we can measure the variance of x and variance of x with respect to the mean value.
What about zeroth moment, sir?
Zeroth moment, yeah, it is an interesting question. The thing is, zeroth moment doesn't have any application, but
Oh,
they use it for like when we are solving the equations, right? That time zeroth moment results in a constant, so they
okay,
don't have
okay.
any physical
Constant.
significance, but
Okay,
they are used for only mathematical calculations while measuring the first moment and second moment.
okay, okay. Moment analysis. Okay, sir.
Kth moment is like not sure about this. Like I have not came across this so far.
Okay.
Let's go with the final question. So final question is like let x be the random variable which represents the yield strength of copper. The expected value of the random variable is 200 MPa. Expected value is E of x is equal to 200 MPa. What is the upper bound that yield strength will be at least 225 MPa. So what they are asking is like uh,
Average plus standard deviation, or
which one, bro? Sorry.
is it same as average plus standard deviation?
Yes, yeah, that's what they are asking. What is the upper bound that? No, that's not average plus standard deviation. We
Okay.
can say it is like the range. What is the upper range?
Upper range. Okay, okay.
So that can result in. So for that, we use this Markov's inequality, where x is a non-negative random variable. So, using this inequality, if the probability that the x value greater than the upper bound value a, it can be given by expected value of x divided by a. So, for that, the expected value of x is already it is given 200 MPa. 200 divided by they are given like at least 225 MPa is the upper bound, so 225. If you divide, means if you uh, simplify it, it will result in 8 by 9. So the probability that the 225 being the upper bound is 8 by 9. So because it is close to the expected value or mean value. So that's
So what is the upper bound means? What is the probability of getting that value?
yes, probability of getting that value from
Will be
the
at least.
with
Okay.
respect to the mean value.
Okay, sir.
Here they have used the upper bound as just a word, but uh, what is the probability of getting 225, which is close to the mean value 200 MPa. So that is
Okay.
the physical significance, physical meaning of this problem. So,
At least 225 MPa. Okay, sir.
so do you have any other questions based on what we discussed? We had this uniform distribution, right? Let's check one.
Yeah, I just want to know the difference between uniform and the normal distribution.
Okay. So uniform distribution means uh, the, the probability for the probability of a function remains constant over a given period. For example, if you take uh, what is it? Rolling a dice,
Mm.
where the probability of getting one and the probability of getting six, 1 to 6, 1, 2, 3, 4, 5, 6, that
Yes, sir.
remains 1 by 6.
Yes, sir. Yes, sir.
So it doesn't change. Uh,
Mm.
so yeah, it is 1 by 6. So it doesn't change with respect to any variable. So if the
Yes,
variable
sir.
is x is equal to 1 also, it will be 1 by 6. When x is equal to 6 also, it will be 1 by 6. But if you
Okay.
take the standard normal distribution, where to change the random variable, the probability of that occurrence changes. So that is what the difference between these two. Did you understand this, or like you want any other example?
The second graph is normal distribution, right?
Yeah, standard normal distribution.
Yeah. So in that case, both are equally left side or right side. So same distribution means mean, median, mode are coinciding. Correct, sir?
You mean the second one here, right?
Second one, yes,
Yeah,
sir.
yeah, yeah. Mean, median, mode is constant.
Okay, sir.
There are other distributions like exponential or Poissons. There, like
Uh,
the probability function varies with respect to the variable rates. So, but
okay.
for uniform distribution, it remains constant over a given range. For example, if I what I can say is like if you have a data set where probability of okay here itself I can say like probability of getting 7 means that is not at all possible. Like even if I have an extra variable like 7 means it will be like 0.
Zero,
So
zero.
how they generally refer this as within this limit it is 1 by 6, elsewhere it is 0.
Okay, correct.
Like that they define this uniform
Okay.
distribution. So yeah, each that's what like if you, while studying statistics, right? We have a lot of
Mm,
distributions. Yeah, taking up the distribution should be decided based on the behavior of that
mm,
variable. Like if
okay.
they, for example, if you take a population, generally it
Mm,
easily fits into the standard normal distribution. But if you take this kind of discrete functions, right, like these uh, can be fitted with Poissons or this can
okay.
be fitted with for example, if you take this problem, this kind of problems like if I take a number of balls from a box, means those things are they will easily fit into the Poisson distribution. So,
Mm,
like that, they will be varying. Where the probability of occurrence is very less, means they will allow come under the Poisson's distribution. Anyway, like
mm,
in later part of the course, right?
okay.
These
Okay.
topics will be introduced.
Okay. So I have few queries about the course.
Yeah.
This NPTEL course will be having online end semester examination, end examination, right?
Yeah.
So yeah, that kind of numerical problems will be can be solved only with the paper and pen type of thing, or any other
Uh,
right
Actually, they
ideas.
will ask you to go to some nearby centers where
Yeah, yeah. We go for
there,
examination.
yeah,
Yeah,
there it is similar to the gate exam only, like how you write the gate
yeah,
exam.
yeah, yeah, yeah.
Similar pattern is being followed. Anyway,
No,
even I'm not 100% sure about this. So your question is like how you will be asked to solve, like whether it is my
yeah,
MCQ question.
numerical problems like if you want to do some calculations, can we use only with the paper pen type of thing? Because calculators are not allowed, I think, mostly.
Okay, yeah, I hope so. Anyway, like I
Uh,
will confirm this. I will ask
okay,
my colleagues and I will confirm it.
okay, okay, sir, sure.
If you will be joining next live session, right?
Okay,
That
sir.
time I will
I think okay. And we can use all the reference materials which is given in the NPTEL website, right? Those reference books.
For studying or like
That
for
is
exam?
for studying, because you're given those lecture materials.
Okay, okay.
Is it possible to get some what you say, some other good reference books PDF which we can uh, use ourselves later? Because this course is mainly with the statistics as well as using R together, right?
Yes, exactly. Yeah.
Yeah. So just to
You
what
want
to say, improve
reference book related to R, or you want reference related to
related
statistics?
to probability and statistics.
Okay, okay.
You
I
can
will.
provide some links. Yeah, something will be in
Yeah,
the reference. Will be nice.
yeah. What I will do is like I will give some reference book along with this YouTube video. Like I will be
Okay.
uploading. The time
Okay.
I will give some reference book along with the
Sure.
basic
Sure.
things. Yeah,
Okay. Okay. Yeah. Okay. That'll be fine, sir.
fine. So you are from which place?
I'm right now in Satyamangalam. It is in Erode district,
Okay, you are from Tamil Nadu.
Tamil Nadu only. Yes.
Okay, okay.
I think it's because of this confusion people are not joined today. Otherwise, you will get a lot of audience and a lot of questions will be there.
Yeah, yeah, yeah. I'm looking forward for that because I'm also learning
Uh,
with these
okay.
courses, so it will be
Okay.
helpful
Okay.
for.
Nice. 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 Because previous time I used to log in for this NPTEL course, I will not be able to allow because Google Meet has crossed the limit. They will not allow me to enter.
Okay, okay, okay.
I was a
Yeah.
little doubtful whether I'll get a chance. Then I see only myself available.
Okay,
It was
okay.
a different experience.
No, generally, it depends on the course. Like, not many
Correct, correct.
people, like, if you go to some, in my similar field, right? If I go to
Yeah, yeah.
artificial intelligence course, or like,
There'll be a lot of
yeah,
people
there will be a lot
there.
of people. Or if I go to some course like welding, for example, in
Correct,
metallurgical
correct.
related, right? I'm from
No, I think here
metallurgical.
also will get more job because a lot of
Yeah,
people might join for this course. I think
I
so.
hope so. Yeah, next time.
Yeah, it'll be nice. Yeah, surely, surely. Thanks a lot for your time. It was nice. It
Yeah,
was
yeah.
very. I mean, for me, it was a lot of things to learn mostly. So
And,
it was useful for me definitely.
yeah, sure. Like you can give your review also based on it. I will try to improve. Like
Sure,
what I
sure.
wanted to do is like I am currently doing a lot of experiments. Like, so it will be
Uh,
I wanted to relate more in terms of the practical
okay.
aspects of the practical aspects and how the data has to be
Yes, yes.
presented and how it has to be analyzed.
Okay.
So that is
I
what.
have one question. Like in this course, is it included that image analysis, interpretation, and data analysis also included, sir?
Image analysis. Um,
At
I
least
think it
something
is.
we can do. Not there.
Yeah,
Okay.
it is not there because as far as I
Suppose we
remember,
get some. Okay. No, at least we get some spectrum like FTR or uh, this one UV spectrum or something, or even SEM image of something.
okay, okay,
We can get to know some things and we can get to know the details, some frequency, some information we'll be getting.
okay.
Can we do further analysis on that data? That is what I was thinking. Because if we
Uh,
give sample for analysis, like SAFE or IIT Madras SAFE, somewhere we get will they'll give the result in terms of these values and chart
hmm.
pictures, right? Graph.
Okay, okay, okay.
So what to infer from those? That will be mostly. I think that is the main aim of the course also.
Yeah, yeah.
How
See,
to
the
interpret
thing
this
is,
data.
for example, if you are getting chemical analysis data, for example, optical emission spectroscopy data means um, the first thing is like we can understand whether the given whether the obtained data is within the uh, given range or given standard deviation
Yes,
or not. These are like very
yes,
basic I'm telling. But
yes, yes. Basic.
for example, if it is a EDS spectrum, if you
Mm,
have done an energy dispersive spectroscopy means we can actually do we can actually take the curves like if it is the
okay.
dispersion spectrum, and from that we can quantify the uh, data, means quantify the given phase, how much
You
is the
can see
phase
that.
fraction.
Okay. Okay.
With those things, I will see like whether it is under the course thing or not.
Okay.
Otherwise,
Yes.
if people request like this, we can
Yeah.
do those things.
At least some discussion on that will be very helpful. So,
Yeah, sure. What I'm planning is
so
like I will bring more my experimental things and I will
okay.
try to make it like more based on
Yes.
current practical session.
Yes. 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 That'll be nice.
Thanks for the input. Yeah, we will discuss based on this.
Okay, okay, sure. Okay, sir. Thank you very much, sir.
Yeah,
It
thank
was
you,
nice
thank you,
meeting you.
thank you.
Thank you. Thanks.